Welcome to this edition of Thoughts from the Big Chair. Now, this week we're joined by TP Chopra, the CEO of BLP Group, which you may not have heard of, but is one of the leading renewable energy generation and technology companies in India. So, first of all, welcome, TP.
Thanks a lot, Russell. Thanks for having me on the show.
Now, listen, and when you and I spoke in advance of this, I know that your business has gone through a number of changes. Maybe it'd be helpful for those listening in to elaborate a bit further on what your business does, what markets it focuses on, and then we can move into how technology has really impacted your business both now and into the future.
Perfect. Thanks so much once again, Russell. So let me just start by sharing a little bit of a story as to how we started the journey and why we even started doing all this. As you mentioned, our core business was power generation. We build, own, and operate wind and solar farms. We were investing very large sums of money in operating all these wind farms and owning all these wind farms. But my background, as I mentioned to you, is I used to be with GE for nearly 15 years. And when I was part of GE, I would tell people turbines never fail, but the reality is turbines do fail. But one day, many, many years ago, one of our turbines burned down to ashes. So that's when I went to all our turbine suppliers and I said, guys, this is not acceptable. That you guys are maintaining all these turbines. I can't have an issue with a turbine burning down. So that's when a few years ago, we started thinking a little out of the box on what should we do to prevent this from happening ever again. So we ended up starting to create an AI and IoT platform. We call it Orion. We started collecting hundreds of tags of data every second from all our wind farms and solar farms. We developed a large number of algorithms so that we could then, in the future, predict failures in these machines. And as a result of that, improve machine availability in these machines from the high 80s and the low 90s to the high 90s. And as a result of that, improve financial returns significantly. So that's how the journey started, Russell. And then over time, what we found is that it was the same kinds of challenges we faced across industries: auto, steel, cement. In every industry today, we have a problem with unplanned downtime and with sustainability. And the reason that studies have shown that $650 billion around the world is lost due to unplanned downtime in manufacturing, and industries are contributing to about 20% of the global carbon footprint. So when you take both these together, what we thought was there has to be some better way, leveraging AI and IoT technologies to really try to solve a problem and making productivity better, reliability better, quality, safety, and cost efficiency across industries in manufacturing.
That's amazing. I mean, that stat jumps out, right? I mean, in terms of around the 650 billion of lost maintenance, it's one of the great use cases why predictive maintenance through IoT is one of those areas where it's a clear way in which you can use IoT for the benefit. Perhaps one of the things which I'd be interested to hear of, because IoT is obviously much talked about, the proverbial fridge that orders your food, but in a manufacturing sense, the application is significant, both in terms of the opportunity to get the data and also drive those efficiencies. What have been some of the challenges you've faced in finding the right sensors, getting them implemented, and trying to use this kind of IoT sensor technology at scale?
Well, Russell, there are a lot of challenges, and I'll just share with you a few. But let me just start by sharing a few numbers at a very high level. You're absolutely right that there are these huge projections in terms of what the numbers are going to be. So that, for example, the global IoT market is predicted to be close to about $500 billion by 2025. The global cloud market is expected to be about over $1 trillion by 2030. And the 5G market is going to grow, from about 2 billion in 2020 to about over $1 trillion by 2030. And all these numbers are just significantly huge numbers. And as a result of it, when you put that in the essence of time, we are really at the start of an incredible revolution that's going to happen across industries and in manufacturing. Now, coming to your question about what are the challenges, for all of us who've been in manufacturing and across industries all our lives, what we've noticed is a couple of things. One, when you go to any factories, you generally find there are all kinds of machines that make up a factory. There are automatic machines, semi-automatic machines, manual machines. Two, you find different machines of different ages on factory floors. They could be a 50-year-old machine, a 20, a 5-year-old, and a spanking new machine on one production line. And the challenge we saw is these machines don't communicate because they've come from different stages. Some have SCADAs, some don't have PLCs. So they just don't communicate at all. So what we started thinking at industry.ai is that the first problem to solve is how do we even figure out how to make all these completely disparate systems communicate to each other. The other big large problem we found was on a production floor, you never have all the machines from just one manufacturer. You might have one from Fanuc, you might have one from GE, you might have one from Siemens, one from ABB, and you have a variety of machines that you put together to make a production line. And that's the other challenge. What we found is that each manufacturer's machines don't communicate to the other. So that's when we were called onto the production floor, and I sort of break it up into 4 stages. The first stage is how do we make these machines communicate, and how do we make them all talk, and how do we extract the data? So what we did was we developed the ability to go into these factory floors and install these sensors on a production floor in order to first just make these machines communicate. And that's not easy. It's much more difficult than it sounds for a couple of reasons. You've got to put it all in context. If you're in a steel factory, and some people who've made steel for 40 or 50 years, they know how to make steel better than anybody else. But this whole sphere and thing about IoT and 5G and all this world of AI is quite something out of the blue for a guy who's made steel for 40 years. So what we're trying to do is try to convince the person that there is value in getting an IoT device onto the factory floor and the benefits of productivity that could come. So that's step number 1, is installing these sensors. Step number 2 is what I call cleaning the data. Now, why is that important? 80% of the data that we would get from, say, a chemical factory, an auto factory, or a steel factory is unstructured data. So the second step is how do we take all this data to clean the data, ingest the data, fuse the data, and scale the data. The third step in the process is once you get all that data in a structured format, that's when we apply the AI algorithms to analyze all this data. And finally, we create the application where we're able to provide these insights to that factory floor, the steel factory, on what actions he should take in order to reduce downtime, in order to improve productivity, in order to improve cycle time or lead time or MTTR or MTBF. That's what we do. So that's sort of the process. But like I said, sometimes I find now, Russell, the challenge is less about the data science part of it. The bigger challenge I sometimes feel is the first 2 boxes or the first 2 steps, which is finding sufficient people in the world that can actually go and climb up cranes or wind turbines, on trains, on auto factory floors, to connect all these machines in the first place, to extract the data, clean the data, then we can do all the data science and insights.
Yeah, it's interesting that from a technological perspective, the challenge that you've got is actually not the data scientists, but the physical installation of these devices. Is that right?
I think if you put it in context and you rack and stack the challenges, that's what I would say. Is that initially, in the early days, Russell, I thought the latter was the challenge, which is how do we develop these algorithms to bring out the right insights? But increasingly, I'm finding that the bigger problem across the world is that CEOs don't have sufficient people who know how to go on the factory floor, make that connectivity happen. Now, why is that important? Because what we need to do is, I call it the triad. To make all these solutions happen, you need 3 things. One is the sensor, which is the device that actually sends the data. 2 is the connectivity layer. So we work with all the large telecom companies to figure out how do we extract the data from the factory floor all the way out of the factory onto the cloud. And the third piece of this whole puzzle is the cloud provider. into which we get the data, we deploy our algorithms onto these cloud providers in order to do the insights. But I just think that today, when you rack and stack all the challenges, the first challenge of actually figuring out which is the right sensor, which is the right combination of sensors, how do we find the right people who understand how to climb up a crane or a train or a wind turbine to put these sensors in the right place is turning out to be a bigger challenge than the data science part of it.
Interesting. But then, when it comes to, I suppose, your point around international operations and being in India, probably a good example, particularly when you go out to some of the more remote areas where you've got bandwidth and connectivity issues. And so how's 5G going to help on that? And, are you using at the moment satellite to get the signal, or is 5G kind of now progressing in such a way that you don't need to worry too much around satellite?
Yeah, no, great question, Russell, and that's the future. There's absolutely no doubt if you just look at what's happening around the world, every telecom company in the world has spent billions of dollars in order to get all these 5G licenses. Now, the strength of 5G, as you know, is low latency, high bandwidth, and therefore your ability to extract vast volumes of data at very low latencies is what it's going to be able to provide. Now, that doesn't, just to put it all in perspective, today's technology is 4G and 4G private LTE. Then comes 5G, but there's no doubt that broadband and fiber is still far, far faster in getting the data out. However, as we go along the future in the industrial world, there are many applications where the cost to lay fiber and connectivity and pipe into the factory at times is more expensive. So you offset a little bit of a downgrade in terms of latency and bandwidth with 5G versus broadband. But nevertheless, 5G is way above the existing technology of 4G. So what I do see, Russell, is that increasingly 5G will become a fairly widely accepted norm in the industrial world to drive Industry 4.0 technologies across the world. But Russell, let me just put this also in perspective. In my view, there are 5 key factors that is really making this whole world of Industry 4.0 and this whole revolution in productivity completely transform the way things are happening right now. And that is the following. One, it's the cloud. And the cloud is obviously making everything more scalable and more cost effective around the world, number one. Number two, sensor prices have declined significantly over the last few years. Point number three is the cost of getting data from any corner of the world has significantly declined. So today, sitting in India, we can get data from wind turbines in France, Germany, Spain, Italy, Portugal, in every corner of the world at a real small fraction of the cost. Fourthly, high performance compute once upon a time used to only exist with a few large companies, but now with the cloud, everybody has access to high performance compute. And lastly, it's about human capital. So companies in the future are those that can attract the right level of human capital to make all these algorithms and AI algorithms happen to really make a difference.
Yeah, really interesting. But going back to that people side for a moment, the ability for mid-sized organizations to attract talent. I suppose in some ways you've got an abundance of talent in India, but no doubt you've got the same challenges as most other countries of trying to attract the right level of data scientists and people that can work on sensor technology to innovate.
You're right, Russell. And I think what's happening is post-COVID, one of the biggest challenges COVID has showed all of us is a couple of things. One, people are going to get more, it's going to be more difficult to make sure we get the right kinds of people and the right skill sets of people into hardcore manufacturing and industry. So that's one. Two, supply chains have been broken during COVID. And therefore, there's a greater dependency to transform productivity and reliability in manufacturing, quality in manufacturing, getting the right kind of people to deploy these technologies. But at the same time, like you said, it's going to be a huge challenge and a war on talent over the next 10 years given the fact that there's going to be a lot of pressure to get the right people. As you know, just the global market for AI systems in the world is predicted to be about $53 billion right now. By 2025, that should be about 145 billion. So we're going to need a lot of incredible talent, data scientists, analytical folks to actually, train all these people. But that's one part of the problem. The other part of the problem, Russell, is how do we bring this technology down for even the smaller MSME companies around the world that may not have the ability to attract large corporations to provide these technologies. And that's what we're trying to do at industry.ai, is really democratize technology to make it really, really simple, affordable for every company in the world, regardless of size and scale.
Yeah. I mean, I suppose one of the things which, Orion, I think it is your analytics engine, is relies on. It goes back to your point about having all of the machines communicate with one another, and the industry you're in, when it comes to some of the asset classes that you service, in heavy industry, renewables, transportation, ports and shipping, oil and gas, manufacturing, right the way across that, obviously highly innovative sectors in many ways, but are you seeing a resistance to the adoption of technologies, and or is that you're saying actually because of COVID, people have kind of woken up to the fact that they're going to need more integrated supply chains, better visibility, and therefore it's actually a benefit for industry.ai when it comes to the current and the future in terms of technology adoption?
Russell, I think I call it the IT versus OT challenge. In other words, a lot of the senior executives and CEOs do understand that if they have to be competitive against their competitors and they want to get to drive industrial competitiveness, they've got to use and adopt these technologies to really drive that next, significant step up in productivity. However, one of the big challenges we find is when you get onto the production floor, there is naturally a certain amount of resistance to adopt these technologies on a factory floor. And that results from a certain element of fear, a certain element that we are not sure that there's going to be a return on investment. We are not sure whether we spend millions of dollars and we're not going to get any real benefit. And that is fair enough. And I tell most CEOs that I talk to that it is a valid concern. And therefore, sometimes when you're trying out new technologies, it's sometimes very, very difficult, as you're aware, to really understand what the cost benefit analysis is going to be and what the real value is going to be. So we do struggle with that quite a bit. But I tell everybody it's a journey. It's a journey that if you ignore at your own peril, you're going to be left behind. So I share with most people that, listen, try it out once, try it on one production line, see the benefits. We will fail. We will learn certain things that we didn't even know about. We will learn certain characteristics of machines that we won't ever know about. But once we get to that cycle, we may fail the first time, but we'll fix the problem the second time, and then we should significantly scale. Let me give you a quick example. For one of the largest port companies in the world, the senior executives of the company absolutely agreed that this was the right thing to do. And they asked us to connect some of the big key cranes that you see on a port. Now, these are large machines. So we actually connected the SCADA PLCs on the factory, on the cranes. In addition, we installed about 48 sensors in each of the cranes. These sensors included vibration sensors, temperature sensors, RPM sensors, pressure sensors. So we installed these 48 sensors and we started getting high frequency data. Now, as you can imagine, Russell, a lot of people push back at that, especially the folks on the board and the chief engineers at the site, because they didn't really think that this was really going to help them in any significant way. And the fact that these cranes are actually quite reliable. After months where nothing really happened at the port, on a certain Friday evening, a couple of weeks back, we found that there was a little bit of a problem in one of the gearboxes. And we immediately informed them, and the system automatically generates an alert to the engineer on the site saying that there's a problem on crane number 5 in the gearbox. Because it was a weekend, nobody really looked at it. On a Sunday, an additional alert went out. But in addition to crane number 5, we sent out an alert that crane number 4 gearbox was also giving a problem. Come Monday, because nobody really looked at the problem over the weekend, come Monday, they found that gearbox in crane number 5 had failed. When they actually opened the gearbox, they found it was so badly damaged that the actual gears had got shorn. Obviously, immediately they shut down crane number 4, and they were able to fix the problem in crane number 4 before the gearbox failed. Now, the gearbox that failed has been shut down for three weeks. I don't see the replacement gearbox coming in still another few weeks because the gearbox has to be imported. Now, in a port, in a normal berth in a port, there are usually 5 cranes. One crane going down, that's 20% loss of productivity, and it's a huge loss for the port. So I think what we've seen, Russell, is that we all learn religion when something goes wrong, and that's what we see time and time again. Just when I learned religion when my turbine burned down. Similarly, I think everybody has to have that one life-changing experience where they then see and realize the power of what technology can do today.
Yeah, that's a really powerful case study. Yeah. And so we are where we are at the moment. There's been a bit of a boost, I think, for most executives across the board, regardless of industry, about, okay, well, we need to start looking at how to adopt technology to improve visibility and use data, particularly post-COVID. Where do you see things going from here, particularly from a kind of IoT growth perspective, given all of the enablers of cloud technology and sensor prices coming down and the availability of distributed data?
I think things are going to vary, Russell, from company to company, industry to industry. As you can imagine, like in everything in life, you can find some industries more at the cutting edge, and there will be some industries that are laggards. But I think by and large, I just don't think of any industry that's really, or any CEO that's not really thinking about how do we drive productivity using these sensors, to how do we drive sustainability. And that's become a really big issue for a large number of companies around the world, regardless of whether you're chemicals or food and beverage, etc. And I think both these things are becoming big concerns. But like all of us know, some industries adopt technologies faster than others, and they are the ones who are going to really see a big jump in the way they adopt technology. Let me just share with you another crazy story about how different the most unexpected sectors are now thinking about adopting new technologies. About 4 or 5 months ago, one of the largest airports in the world approached us and said, listen, TP, we want to think about, is it possible for us to run an entire airport operation using computer vision AI that's never been done before? Now, most airports in the world actually use a sensor that's actually was made maybe many, many years ago. But the sensor is very expensive and usually deployed in only a couple of places in an airport, like in immigration or security or in baggage check-in. And all it does is just one thing, which is detect occupants or the occupancy in that certain area. Now, what this airport came and told us was, listen, what if we can connect 2,500 cameras to think about use situational awareness using AI to run an entire airport? So we started this journey some months ago to test the possibility to see even if we can do this. And the results have been absolutely outstanding. Because if you think about it in an airport, the CapEx has already been made. You've already got the cameras that were installed many years ago. So that's money already spent. So you don't need any new CapEx, no new investment. And what we started doing was connecting these cameras and then collecting all the data and then analyzing the data. Now, the fun comes in not only on the monitoring part of it, is how do you take all this to then provide certain actions? Now, when you take a step back, what really drives an airport are 2 real critical things: customer experience and operational efficiency. What is customer experience? How much time do each of us take when we go through baggage check-in, security, immigration? How do you make that whole experience a really good one? How do you make the whole retail experience a really good one? Similarly, for operational efficiencies, how do we reduce the energy costs in an airport? How do we track all the APUs, GPUs, trucks, oil tankers? How do we track all this to ensure that the utilization of all these assets are being utilized well on an airport premises? So we started this project some months ago, and the results have been just phenomenal. Because think about it, using situational awareness, you connecting up all these cameras, the use cases are run into hundreds. So now we can predict how much time it would take for you and me to go through security, baggage checking, immigration. And we actually set thresholds to say that if the airport authorities decide that nobody should spend more than 2 minutes, 3 minutes at any choke point or dwell point in the entire airport, we can immediately send out alerts to say that somebody's spending more than 3 minutes or he's stuck at half an hour in security, and certain actions can be taken. Similarly, resource allocation in airports. Why is it that I always end up standing in the wrong queue at an airport because my queue always takes the longest and everybody else's queue goes the fastest? But what if we can use these algorithms to decide or inform me that TP, go to gate number 3, not to gate number 1, because it'll take you only 10 minutes to go through gate number 3, not the 20 minutes at gate number 1. So these are the kinds of things that I'm seeing, Russell, that in the most unexpected industries and airport, that how they too are thinking about the adoption of technologies in this post-COVID world in order to drive operational efficiency and customer experience.
Yeah, another fantastic example, and kind of reassuring in many ways that I'm not the only one in the longest and slowest queue trying to go through security. Really, really interesting. And I think what you've done really is brought to life the fact that, when we're in a post-COVID world where, it actually is safer to make sure that you're looking at all of the workflows and keeping people moving in a safe and secure way. But equally, that has real world impacts on operational efficiency, and using technology, whether it's incumbent technology that's already there, or sensors that are added to it, can generate vast amounts of data that drive insights. And so, all of that to the point where you've really brought insights from different industries and different perspectives to combine the cloud, the sensor, the data, and the compute. And not for today, but one of the topics which we'll come on to in the series will be around, whilst you've got all that data, how you keep it safe and secure, because that's the other side of this, which is an abundance of data, but making sure you're keeping it safe and secure is one of the topics we'll be covering in this series. But in the meantime, I just want to say, TP, thanks very much for everything that you've shared today. It's been a terrific insight on your business and some of the challenges that your clients are dealing with. So many thanks for taking the time, and look forward to catching up again with you soon in the near future.
Well, thank you very much, Russell, for having me in the show, and hopefully all of us can collaborate to make the world a better place going forward.
Absolutely. Yeah. All right. Well, amen to that. And let's leave it there for today. But thanks very much again.